Okay, in this video I'm going to show you the derivative or the derivatives of trigonometric functions. So let's put a title to this video. So the derivative of the trigonometric functions. Trigonometric functions. Okay, so let's start with the function y is equal to sine x. The derivative of y equal to sine x is cosine x. There is a proof on how we can get the derivative directly, but that will not be covered in this video. But rather, I'll be presenting the derivatives of the trigonometric functions. So if y is equal to cosine x, the derivative is equal to negative sine x. If y is equal to tangent x, the derivative is equal to secant squared x. If y is equal to cosecant x, the derivative is negative cosecant x cotangent x. If y is equal to secant x, the derivative is equal to secant x tangent x. And finally, if y is equal to cotangent x, the derivative is equal to negative cosecant x squared or cosecant squared x. Now you might be asking, how can I easily remember the derivatives of the trigonometric functions? So first off, I know that there are pairs of functions in this set of derivatives. For instance, sine x will always go with cosine. So in the cosine, you expect the derivative to be sine. Tangent will always go with secant, so the derivative of tangent is secant squared x. Cosecant will always go with cotangent, so there's still one cosecant, but the other function is cotangent. That's why when you look at cotangent, the derivative is a cosecant. The secant, as we mentioned a while ago, will always go with tangent, so the derivative is secant tangent x. Now, aside from that, the secant and cosecant will always appear twice. So if I know that if the derivative of tangent x is something with a secant, I already know that it should be secant squared because the secant should appear twice. Like if you look at y equals secant x, we know that the secant will appear twice. So you have secant already here, so it should appear again on the derivative, and then followed by tangent x. For cosecant, so if you look at cosecant already appeared here, so it should appear again and then cotangent. That's why for cotangent, if we know that the partner, or say the pair is cotangent and cosecant, the derivative should be cosecant squared x because cosecant should appear twice. This is just my way, so you can always devise your own way on how to remember these things. But for me, that really worked for me. Now, if you look at it, some of the derivatives have a negative sign. So negative in terms of the symbols. It's a negative, and it's a negative. One way for me to easily remember that is that whenever I get the derivative of a function that starts with letter C, the derivative is always negative. So take a look at cosine. Cosine starts with letter C, so I expect the derivative to be negative. Now let's find another function that starts with letter C, cosecant. So we can expect that the derivative is negative. Another function that starts with letter C is cotangent. That is why the derivative is negative. So again, that's just a way for me to remember it. There is no mathematical explanation to it unless you do the proof of the on how we can get these derivatives. Okay, but this for easily for us to easily remember the derivatives, so I use those techniques. Okay, so again, let's review. So the pairs, so sine, cosine, tangent and secant, cosecant and cotangent. And then the signs, they start with any function that starts with letter C will have a negative derivative. And the third one is secant and cosecant will always appear twice. Okay, so I hope that was able to help you in easily remembering the trigonometric or the derivative of the trigonometric functions. Okay, that's it.